Balancing a 30 kilowatt three-phase generator output to a 15 kilowatt single-phase load while maintaining a voltage close to utility voltage of 115/230 volts can be achieved using a couple of techniques. This requires a three-phase generator with a capacity of 30 kilowatts and voltage options of 120/208 volts, 127/220 volts, or 139/240 volts, two single-phase transformers rated at 15 kilovolt amps each, and a transfer switch. The procedure involves a few key steps. Firstly, utilize the two single-phase transformers to balance the three-phase generator output. Connect the input of both transformers in parallel to two of the generator's three phases. Secondly, select the generator output voltage, either 120/208 volts or 127/220 volts, which provides a voltage close to the existing utility voltage. Thirdly, distribute the load. Since the total load is 15 kilowatts, each transformer will handle 7.5 kilowatts. Connect the 120 volts loads to the output of the first transformer and the 230 volts loads to the output of the second transformer. Lastly, install a transfer switch that automatically switches the load from the utility supply to the generator output when the utility supply is lost. The generator output voltage will be slightly different from the utility voltage due to the voltage drop in the transformers. However, by selecting the appropriate generator output voltage and transformer size, you can minimize this difference. For example, if the generator output voltage is 127/220 volts, the voltage at the load terminals will be approximately 127 volts for 120 volts loads, which introduces a minor 1.7% voltage drop, and 220 volts for 230 volts loads with no voltage drop. The advantages of this approach include a balanced generator output to prevent phase imbalances in the single-phase load, maintain voltage stability that is close to the utility voltage, ensuring compatibility with the load, and flexibility, allowing for the use of different generator output voltages depending on availability and load requirements. The selection of the appropriate generator output voltage is critical to ensure that the voltage supplied to the single-phase loads is as close as possible to the utility voltage. The use of a transfer switch allows for a seamless transition between the utility power and generator power. The parallel connection of the transformers to two of the three phases ensures that the load is distributed evenly across the phases. The 15 kilovolt amps rating of each transformer is sufficient to handle the 7.5 kilowatt load. There are a couple of safety considerations that should be kept in mind. All electrical work should be performed by a qualified electrician. The generator should be properly grounded to prevent electrical shock. The transfer switch should be installed in a safe and accessible location. The transformers should be protected from overload and short circuit. The generator should be properly maintained to ensure reliable operation. There are also a few potential issues that may arise. The voltage drop in the transformers may be too high, requiring the use of larger transformers. The generator may not be able to supply enough power to meet the load requirements. The transfer switch may fail to operate properly. The transformers may overheat if they are overloaded. The generator may produce excessive noise or vibration. Some alternative solutions may involve using a rotary phase converter, a solid-state phase converter, or a three-phase transformer. However, these solutions may be more expensive or complex than using two single-phase transformers. Balancing the load across the three phases of the generator is important to prevent overheating and damage to the generator. Using two single-phase transformers is a cost-effective and efficient way to balance the load. The selection of the appropriate transformer size is crucial to ensure that the transformers can handle the load without overheating. The installation of a transfer switch is essential to ensure a seamless transition between utility power and generator power. The generator should be properly maintained to ensure reliable operation during a power outage. The system should be tested regularly to ensure that it is functioning properly. This solution provides a reliable and cost-effective way to provide backup power to a single-phase load using a three-phase generator. The use of two single-phase transformers allows for balancing the load across the three phases of the generator. The transfer switch ensures a seamless transition between utility power and generator power. The system should be designed and installed by a qualified electrician to ensure safety and reliability. Furthermore, the voltage comparison is essential for ensuring compatibility between the generator output and the existing single-phase loads. The balanced output of the transformers helps to maintain voltage stability and prevent damage to the generator. The flexibility of using different generator output voltages allows for adaptation to various load requirements and generator availability. In this procedure, it is assumed that the three-phase generator is capable of producing the required power output for the single-phase load. The transformers must be sized appropriately to handle the load current without exceeding their rated capacity. The transfer switch must be rated for the voltage and current of both the utility supply and the generator output. Proper grounding and overcurrent protection are essential for the safety of the system. Regular maintenance and testing are required to ensure the continued reliability of the system. The use of two single-phase transformers connected in parallel to two phases of the three-phase generator effectively creates a single-phase output that can be used to power the single-phase load. This approach minimizes the imbalance on the three-phase generator, which can improve its efficiency and lifespan. The transfer switch allows for a seamless transition between the utility power and the generator power, ensuring that the load is always powered. The selection of the appropriate generator output voltage is crucial for minimizing the voltage drop in the transformers and ensuring that the single-phase loads receive the correct voltage. The advantages of this solution include its simplicity, cost-effectiveness, and ability to balance the load on the three-phase generator. Possible limitations include the voltage drop in the transformers and the need for regular maintenance and testing. The generator should be located in a well-ventilated area to prevent overheating. The transformers should be installed in a dry location to prevent corrosion. The transfer switch should be easily accessible for operation and maintenance. The system should be inspected regularly for any signs of damage or wear. All electrical connections should be tight and secure. The grounding system should be properly maintained to prevent electrical shock. The overcurrent protection devices should be sized appropriately to protect the equipment from overload and short circuit. The system should be tested under load to ensure that it is functioning properly. The single-phase load should be distributed evenly between the two transformers to balance the load. The voltage drop in the transformers can be calculated using the transformer impedance and the load current. The generator output voltage should be adjusted to compensate for the voltage drop in the transformers. The transfer switch should be tested regularly to ensure that it is operating properly. The system should be inspected by a qualified electrician on a regular basis. The single-phase load should be protected from voltage surges and spikes. The generator should be equipped with a low oil shutdown to prevent damage to the engine. The system should be designed to comply with all applicable electrical codes and regulations. The use of two single-phase transformers provides a simple and effective solution for balancing a three-phase generator output to a single-phase load. This approach minimizes the imbalance on the generator, improves its efficiency, and extends its lifespan. The transfer switch ensures a seamless transition between utility power and generator power, providing a reliable backup power source. Proper installation, maintenance, and testing are essential for ensuring the safety and reliability of the system. Selecting a generator voltage close to the utility voltage minimizes voltage differences during transfer. Distributing the single-phase load evenly between the two transformers further balances the generator output. A transfer switch is key to safely and automatically switch between utility and generator power. By understanding these principles and following the outlined procedure, you can effectively balance a three-phase generator output to a single-phase load.